Hello friends, welcome back to my YouTube channel. Today I'll be discussing part 8 of storage vessels. Part 8 of my discussion on storage vessels, and in this I'll be talking about design of flat bottoms for storage vessels. So this is the last part of storage vessels. In my next video, I will be discussing one numerical where I will discuss how to design a storage tank with a self-supporting conical roof. As far as the theoretical aspect is concerned, this will be the last part of my discussion on storage vessels. And as I said, I'll be talking about how to design a flat bottom. This is a very brief discussion on design of flat bottom for storage vessels, vertical cylindrical storage vessels. But I hope this is going to help you to design flat bottoms for those storage vessels. So let me start my discussion. The flat bottom is constructed from flat plates. So the bottom of the storage tank, tall vertical cylindrical storage tank, it is a flat bottom that is made up of flat plates. The plates are lap welded. How they are joined? They are joined by using lap welded joints. The plates are lap welded, and if they are lap welded, there will be overlapping. And what care is to be taken with this overlapping? The overlapping should be greater than 5 times the thickness of the thinner plate. The overlapping distance should be greater than 5 times the thickness of the thinner plate in the bottom. Now, support for the bottom of the tank, you can have fully supported flat bottom, so that can be supported on a concrete slab, or that can be supported on a consolidated and a leveled ground. So if you are thinking of providing fully supported bottom, then you can rest it on a concrete slab, or you can simply rest it on a consolidated and level ground. For example, this could be a concrete slab, and the flat bottom of the storage vessel can be directly resting on this concrete slab. If you are thinking of supporting the bottom on beams, then the beams will be attached. Number of beams will again depend on diameter. So for example, I have shown how two beams are used for supporting the bottom of the tank. Now let us talk more about fully supported bottoms. These fully supported bottoms, they are subjected to direct pressure of the liquid, direct hydrostatic pressure of the liquid. But more or less, they are not subjected to bending moment. The only important factor, the only important load in case of fully supported bottoms that are resting on a concrete slab or a leveled ground. So in that case, the hydrostatic pressure is important. They are subjected to direct pressure of the liquid, and they are rarely subjected to bending moments. So for example, again I am showing the flat bottom resting on a concrete slab. So the important load will be the hydrostatic pressure pH that will be acting on the bottom of the tank. In case of large tank diameters, even if you are supporting, if they are in case of large tank diameters, even though the bottoms are fully supported, some portion of the ground may settle unevenly. This can happen in case of large diameter tanks. In case of large tank diameters, some portion of the ground may settle unevenly, and uh, in this case, if this happens, the support to the bottom will not be uniform. And taking this fact into consideration, a minimum thickness of 6 mm is required. So if you have large tank diameters and they are fully supported, and there are chances that some portion of the ground may settle unevenly, and due to which the support will not be no longer will no longer be uniform. In that case, you have to ensure that minimum thickness should be 6 mm. Minimum thickness should be 6 mm. For tank diameters greater than 12 meter, you may also need an annular ring of segmental plates in order to make strengthen this. And then minimum thickness for this segmental plates will be 8 mm. The minimum thickness for segmental plates is 8 mm. Now let us talk about tanks that are supported on beams. When this is done, when a clearance is required, clearance under bottom is required. Tanks, they are supported on beams if clearance under bottom is required. The bottom is then subjected to bending moment. So bending moment will become due to the liquid in the tank. So you have a flat bottom tank supported on two beams. Liquid will be exerting the hydrostatic pressure of the liquid. It will be acting over here, and it will be creating a bending moment for this bottom. The unsupported part of the bottom, that means we are talking about this unsupported part of the bottom, it is equivalent to a rectangular plate. So you can consider this part equivalent to a rectangular plate that is uniformly loaded due to liquid in the tank, and it is supported at the periphery. So this will, you can consider this as a rectangular plate that is uniformly loaded due to the weight of the liquid, and that those plate that plate is then supported at the ends. These beams will be acting as the end supports for that rectangular plate. So the point is, in case of tanks tanks supported on beams, this is done when clearance is required. Clearance under the bottom is required. The bottom will be subjected to bending moment. In this case, the unsupported part of the bottom will be acting as a rectangular plate that is uniformly loaded due to weight of the liquid in the tank, and which is supported at the ends by this beam. So it will be a rectangular plate. The unsupported part will be will be a rectangular plate that is uniformly loaded due to liquid pressure, and that rectangular plate is uniform supported at the periphery, at the ends. Okay, then the equation that is useful, the maximum stress developed. In this case, the important thing is weight of the liquid. So maximum stress that is developed due to the weight of the liquid is given by this equation. F max is equal to pH into B square divided by 2 into TB square into 1 upon 1 plus B square upon A square. And what are the terms involved in it? A is the longer side of the plate, B is the shorter side of the plate, TB is thickness of the plate. If you want to determine the thickness, you can use this formula. So pH will be your hydrostatic pressure, A and B will be the dimensions of the plate, F max will be the permissible stress, so you can use it to find the thickness of the plate. pH is hydrostatic pressure, so this can be used to find the thickness for the bottom plates. So with this I end my very brief discussion on design of flat bottoms. So in my discussion I have given an idea of how you can carry out the design of a flat bottom tank. You please remember the minimum thickness that needs to be provided to the bottom plate, and then you can think of using this formula for calculating the thickness of the plate. Okay, so thank you for being with me. Thanks for watching my video. This is the last part of my discussion on storage vessels. In my next video, I'll be discussing a numerical where I will tell you how to design a storage vessel that is having a self-supported conical roof. So thanks for watching. Do subscribe to my YouTube channel. Please tell your friends to subscribe to my YouTube channel. Be with me to know more about chemical engineering. For now, have a nice day. Thank you. Bye bye.